Okay guys, so let's start for the first question. Okay, so we're gonna find the mass of methane based on these questions. We use the formula N equals to PV per RT. For P we use 103,000 times 5.37 times 10 to the power of minus 3 per 8.31 times 333. It got from the 60 degrees Celsius plus 273 to change it into Kelvin. And then we got it 553.11 per 2767. So it equals to 0.2 mole. And then after this, we gotta find the mass with the formula mole times molarity. So the molarity of the methane is 0.016, and then we will times it by the mole 0.2. We got it 0.0032 kilograms, and then we change it into grams times 1000, and then it will be 3.2 grams. Okay, next questions. This is number of electrons in the sodium ion and the azide ion. So sodium plus, we're gonna use the formula electron minus ion. So for sodium ion, the ion is 1, so it's 11 minus 1 equals to 10. And for the azide, the electron is 7 times 3 because it was N3 minus, so it was 21 plus 1 is the ion, so it equals to 22. Okay, next to solve these questions, we have to change the temperature first from Celsius to Kelvin. We have to plus it by 273, so it equals to 308 Kelvin. So after that, we use the formula N equals to PV per RT. For P, we use 1 times 10 power of 5 times 6 times 10 power of minus 6 per 8.314 times 308. It equals to 0.6 per 2561.96. It equals to 2342 times 10 power of minus 4. And then for the volume is 200 centimeters power of 3. We changed it into decimeters power of 3. So we have to divide it by 1000. So it equals to 0.2 dm power of 3. And then after that, to find the concentration, we use the mole of oxygen per volume. So it was 2342 times 10 power of minus 4 per 0.2. It equals to 1.17 times 10 power of minus 3. And next, the answer is non-linear because the structure is gonna be bent. The answer is H2O and SCl2 because their structure is same. It's non-linear or bent. Next, how to find the percentage abundance of 24 magnesium is, we use the formula 24.3 equals to 24 times x plus 25 times 100 minus x per 2 plus 26 times 100 minus x per 2 per 100. So 2430 equals to 24x plus 51 times 100 minus x per 2 equals to 4860 equals to 48x plus 5100 minus 51x equals to 3x equals to 240. So x is 80%. Okay, for these questions is B because it represents the overlap of two orbitals. So to find the enthalpy change of these questions, first we have to find the volume. It's 25 plus 25 equals to 50 centimeters cubic or 50 grams. And then the delta temperature is 30 minus 15, so it equals to 15 degrees Celsius. So for the Q equals to MC, delta temperature is 50 times 4.18 times 15. It equals to 3135 joule or 3.135 kilojoule. After that, we find the mole of HCl is 0.025 times 4. It equals to 0.1 mole. So the enthalpy change is Q per N equals to 3.135 per 0.1 equals to minus 31.35 kilojoule mole minus 1. So to find the enthalpy change of these questions is enthalpy change equals to enthalpy change of product minus enthalpy change of reactant. It's 140 equals to 2 times minus 394 plus 3 times 286. So we just calculate it. We got minus 1646 plus 140 equals to enthalpy change of ethane. So it's minus 1506 kilojoule mole minus 1. It's B. Okay, to find the enthalpy change of combustion of carbon, we use the enthalpy change of product minus enthalpy change of reactant. So it's minus 158 equals to 2 times enthalpy change of carbon plus 3 times minus 286 minus 1560. So it equals to minus 158 equals to 2 times enthalpy change of carbon minus 858 plus 1560. So it's minus 158 equals to 2 times enthalpy change of carbon plus 720. So it minus 158 minus 720 equals to 2 times enthalpy change of carbon. So enthalpy change of carbon is minus 860 per 2. It equals to minus 430 kilojoule per mole. So for the definition of standard enthalpy change of neutralization is when an aqueous acid and an aqueous alkali react together to produce 1 mole of water. Okay, to find the enthalpy change for this reaction, first we have to reverse the position of the first equations and then we times it by 2. So it's plus 296.5 times 2 equals to 593 kilojoule. And then after that, for 2SO2 plus O2 equals to 2SO2 is the enthalpy change is 593 minus 791.4. It equals to minus 198.4 kilojoule per mole. So for these questions, for the first equations, we divided by 4. So it's minus 904 divided by 4 is minus 226 kilojoule. And then for the second equations, we divided by 2. So the enthalpy change is minus 114 divided by 2 is minus 57 kilojoule. And then for the third equations, we divided by 4. So the enthalpy change is minus 87 kilojoule. So for the enthalpy total is minus 226 minus 57 minus 87 equals to minus 370 kilojoule per mole. So for these questions, to find the enthalpy change of the reaction is first we have to know the volume. It's 25 plus 25 equals to 50 centimeters cubic or 50 grams. And then the delta temperature is 2.5 degrees Celsius. So the Q is MC delta temperature is 50 times 4.18 times 2.5. So the mole of NaOH is volume times concentration. So for volume, it's 0.025 because we convert it from grams into kilograms. And then after that, times 0.1 as the concentration. So it would be 0.0025 mole. And then after that, enthalpy change is Q divided by N. So it's 522.5 per 0.0025 equals to minus 209 kilojoule per mole. For this question, first we have to know mole of HNO3. So it was 0.02 times 4, it equals to 0.08 mole. And for mole NaOH is 0.03 times 2, so it's 0.06 mole. And then after that, we have to find the Q. It was N times the minus delta enthalpy. so it was 0.06 times 57, and the mole that we use here is the mole of NaOH, so it equals to 3.42 kilojoule, and we convert it to joule is 3420 joule. And then after that, we have to find the volume is 20 plus 30 centimeters cubic. It will be 50 centimeters cubic. And then after that, the formula of Q is volume times C times delta temperature. So it's 3420 equals to 50 times 4.2 times delta temperature. So the delta temperature is 3420 divided by 210. So the delta temperature is 16.3 degrees Celsius, and then we place it by 25 degrees Celsius as the total temperature, so it will be 41.3 degrees Celsius. So for these questions, we have to find the enthalpy change is enthalpy change of glucose minus 2 times enthalpy change of ethanol. So it's minus 2820 minus 2 times minus 1380 and 68. It equals to minus 2820 plus 2736 equals to minus 84 kilojoule per mole. So for questions number 31 and 39, the answer is C, because this HCO3 minus is acting as a base. So for these questions, the answer is B, because magnesium oxide is a strong base. So if it mixed by magnesium chloride, it will produce a solution with the highest pH. So this answer is B, because for NaOH, if the Phi is 1 dm power of 3, the concentration it will be 1 mole dm power of 3. So mole is 1 times 1 is 1 mole. And for H2SO4, if the Phi is 0.25 dm power of 3, then it will get times by 2. It will be 0.50 mole. And because of H2SO4 have 2 H, so 0.5 times by 2, and it will produce 1 mole of water. So for these questions, water behaving as a Bernoulli base is B, because in this question H2O has to accept ion H plus from H3PO4 to be H3O plus. So for these questions, the answer is A, because from the second equation, it shows that SO3 2 minus is accept proton H plus from HSO3 minus to be a SO3 2 minus. So the correct choice is A.